Okay, so last class period we just barely touched on 1.3. Today we're going to go over and finish 1.3. And 1.3 is going to take quite a bit of time to go through because these are applications. And we need to make sure we know how to set these up and solve them because you're going to see them again in college algebra. So we're in 1.3. And we're going to be pulling problems from our textbook here. So we'll go over a couple of each type. And we're going to start with questions that involve geometric figures. So we're just getting ready to get started. We're in 1.3. And we're going to look at question number 30 on page 88. So we'll be on page 88 of your textbook. We're going to look at question 30. On these questions, we really want to take our time. Read them. And if we need to, we'll go look up formulas from the back cover. What I usually do is I read it through once. And then we look at it sentence by sentence. So this is on page 88, question 30. The John Hancock Center tapers as it rises. The top floor is a rectangle, and it has a perimeter of 520 feet. The width of the top floor measures 20 feet more than 1/2 its length. What are the dimensions of the top floor? Now, they have it all diagrammed out here. Okay, we have to be careful because we're not worried about the bottom floor. What are we only worried about? The top floor. Okay, so this is what we've got for our top floor. Now, what do we know about the perimeter? Let's take a moment to discuss what the perimeter is, how we find it. Well, the perimeter, doesn't matter the figure, is always the sum of all sides. So the perimeter is always going to be adding up all of our sides. And in our case, our perimeter is 520 feet. Now we're not going to put units of measure on till the very end. So perimeter is the sum of all the sides. That's going to be 520. Now, we're not worried about the bottom floor. We only worry about the top floor. So let's look now at the top floor. Let's draw that out. Our top floor looks like this. They've got it drawn out for you. And they've got this labeled as L. And then we've got 1/2 L plus 20. I'm going to label it all the way around. So there's an L at the top and a 1/2 L plus 20 on the left as well. So that's the top floor. Right, so we just looked at it. We first found that perimeter. We looked at the picture that they gave you. We're only concerned about the top floor. Now, what do we know about that perimeter? Well, that perimeter is going to be the sum of all the sides. So that means we have 1/2 L plus 20 plus L plus 1/2 L plus 20 plus L equals 520. So that's what we've got there. Does everyone see where we came up with that? So we just added up all the sides all the way around. Now we can combine like terms together. So we've got 1/2 of an L and 1/2 of an L. That's 1 L. Another one makes 2, and another one makes 3. So we've got 3L, because the 1/2 and the 1/2 goes together to make it 1. One more makes 2, and the 1 on the end makes it 3. So we have 3L. And then 20 and 20 makes it a 40. Now we've got our equation condensed down, and we can solve it from here. So then we simply move that 40 over with subtraction, and that leaves us then with 3L equals 480. We'll divide by our 3. And that gives us then L equals now what? We divide 480, divide that by 3. We end up with L equaling 160. Now we need to make sure we completely answer the question, because this may or may not be our final answer. And it's not, because it says, what are the dimensions of the original base? So we want the length and the width. So we have to find both. Now our length is L. And we found L to be 160. Make sure we put our units of measure on. And in this case, our units of measure are in feet. So the length of that top floor is 160 feet. We also need to find the width. Okay, so we need to find the width here. And the width, what is that? The width is 1/2 L plus 20. So that's 1/2 times 160 plus 20. Half of 160 is an 80. Plus 20 then makes it 100 feet. So it's 160 feet wide, or long, right? And 100 feet wide. So we found our formulas, we plugged them back in, and we completely answered the question. So don't just stop at the 160, because that may not be all of it. You have to make sure that you answer the question. And it wants the dimensions, so that means we had to find both the length and the width. We worked it out using the provided picture and got our answer. Let's look at another one. Let's look at question 33. This is a triangle problem. And this one's discussing the Bermuda Triangle. Now, what do we know about our triangle? So while you're copying down the last question, what do we know about a triangle? A triangle's got 3 sides, right? So when we talk about the perimeter of the triangle, what are we going to do? Add up all the sides. And there's going to be 3 of them. So question 33. The Bermuda Triangle supposedly causes trouble for aircraft pilots. It has a perimeter of 3,075 miles. The shorter side measures 75 miles less than the middle side, and the longest side measures 375 miles more than the middle side. Find the lengths of all 3 sides. So, a lot of information going on in this question. First thing we're going to look at is that 3075. Now, what is that 3075? That is your perimeter. So that's the sum of all the sides. And we're going to break that down into the longest side plus the middle side plus the short side. Because the triangle has 3 sides, and they're all going to be different. So that's what the perimeter is, adding up all the sides. This one's a little bit more difficult because we need to come up with our equation, and we need to see how all the sides relate to each other. So we got the longest side, the middle side, and the short side. So now we need to read this question, the second half of this question, and figure out what goes where. We're going to write it up with words, then we'll transfer those words into variables to come up with our equation. So the shortest side measures 75 miles less than the middle. So the short side is going to be the middle minus 75. So we'll write it up in terms of words first, and then we'll use the variable. So the short side is going to be the middle side minus 75. The longest side measures 375 more than the middle. So that's going to be the middle plus 375. Now, the one that we know nothing about is going to be called the variable x. So do we know anything at all about the middle side? No, that's going to be our unknown. So we're going to put the x here. Now we can rewrite this all in terms of x. So now we can rewrite this as the longest side is going to be x, because that's the middle, plus 375. Because remember, we called the middle x. So that comes here. The middle side, again, is simply x. And the short side is the middle minus 75. So that's going to be x minus 75. So is everyone okay with how we dimension it all out? Now, we know that that perimeter is 3075. And that's the sum of all the sides. So now we can fill it in. So the longest side, well, that's going to be x plus 375. The middle side, we found that to be x here. And then the shortest side, well, we found that to be x minus 75. And that's all going to equal our 3075. So does everyone see how we did it in terms of words? Then we rewrote it with the variable x. And then we used our perimeter. We plugged all of our pieces in. And now we've got an equation that we can actually solve. So we're going to go ahead and combine. So we've got 1, 2, 3 x's. And then we've got 375 minus 75. So that's going to be a plus 300 here. That equals your 3075. We're going to now take away that 300. And that leaves me with 3x now equaling 2775. Divide by our 3. And now we've got part of the answer. Not the whole answer, part of the answer. 2775. We're going to divide that by 3. That gives you 925. Now we should be able to get all 3 sides. So we'll start over here with the longest side. So that's going to be 925 plus 375. So we can see here, because we're just going to work it out over here. So 925 plus 375. Well, that comes out to be 1,300 miles, not feet. So there's your first piece, 1,300 miles. That's the longest side. And we need our middle side. We found that to be x, and so that's 925 miles here. And then we also need our short side. And our short side would be 925 minus 75. And that comes out to be 850 miles. If we wanted to check our answer, how can we check our answer? Well, what do we know? we know that perimeter is 3075, right? So if I add up all the sides, what should they add up to give you? 3075. So if we want to, we can check. You don't have to, but we can go ahead and check because we can just add these up. So we have 1300 plus 925 plus 850. That comes out to be 3075, so we know we did it correctly. And so our answer on this one would be 1300 for the longest side, 925 for the middle, and 850 for the short side. So that's how to solve geometric figures and problems. Most of these are going to be using the perimeter. And what's the perimeter? Adding up all the sides. It doesn't matter what type of figure it is. Anytime we talk about perimeter, you add up all the sides. So next we're going to look at some comparison problems. These are actually, I think, a little bit easier. So we're going to be comparing two different people or two different companies together. So we'll look now at, how about question 38? And this is going to be on page 89. And this is a comparison type of problem. And we're going to be comparing some salaries here. So in 2017, the LA Dodgers and the New York Yankees had the highest payroll in Major League Baseball. The Dodgers' payroll was $40.6 million more than the Yankees' payroll. And together, they totaled $443.6 million. What was the payroll for each team? Now, we first, when we want to compare them, we need to find our total. And what's our total? I always like to start with the total. So how much total do we have from both of them put together? The total is going to be that $443.9 million. So that represents my total there. Oh, sorry, 6, not 9. Yep. 443.6. About that. So that's a 6 there. Now, what does that mean when I talk about the total? When I talk about the total, well, that's going to be the Dodgers plus the Yankees. So that together gives you 443.6. Is everyone okay with that so far? So that's what we've got. Now, I always like to start with words and then turn it into the variables after that. So we've got the Dodgers and we've got the Yankees. And how do they relate to each other? Well, it says the Dodgers' payroll was $40.6 million more than the Yankees. So that means the Dodgers is going to be the Yankees plus that $40.6 million. I'm not putting units on until the very, very end. Now, do we know anything at all about the Yankees? No, it doesn't tell us anything about their salary. So that's going to be our unknown X. So one of them is always unknown. And now we can rewrite this as the Dodgers equals X plus 40.6. And the Yankees are going to be X. So we replace it with the variable X for the Yankees. And that now gives us our two parts. Filling it in, we've got the Dodgers, which is X plus 40.6. We've got our Yankees, which is now X, and that equals 443.6 there. We've got our equation. We can solve it. So combining like terms, we've got X and another X, so that makes it 2X plus 40.6 equals 443.6. We're going to move that 40.6 over with subtraction. Now we have 2X equaling, moving that over, we've got 443.6, subtract off 40.6. That gives you a difference of 403. We'll divide that by our 2. And now we have X equaling 201.5. Now make sure we answer the question. So what do we want? We want to find both their salaries. So starting over here with the Dodgers. How much did the Dodgers make? Well, the Dodgers made X plus 40.6. So that's going to be 201.5 plus your 40.6. And so then the Dodgers payroll was 201.5 plus 40.6. Type it in here, right? Adding those together, that's 242.1 million. $242.1 million. That was the Dodgers. And what about the Yankees? Well, the Yankees is X, so the Yankees is $201.5 million. Is everyone okay with that one? You see what I did? So make sure that when you solve it, you actually answer the question. In this case, it wants both. Not just one of them. You'd only get half credit if you stopped that 201.5. So make sure you take it, plug it back in, and get the other one. Let's do one more of these. Again, I'm going to try and do 2 of each type at least. Question 40. This one is 2 Major League Baseball players again. We're going to be comparing Ted Williams and Roger Hornsby. Anytime you have a total, you're going to solve it like this. So Ted Williams and Roger Hornsby were 2 great hitters in Major League Baseball. They had 5,584 hits together in their career. Hornsby had 276 more hits than Williams. How many hits did each player have? So again, first thing I always like to do is come up with our total. And so our total in this case is the number of hits. And total they have 5,584. And that's going to be Roger Hornsby plus Ted Williams. So Ted Williams and Roger Hornsby together gives you 5,584. Now we need to compare them. So we're looking at Williams and Roger Hornsby. And we're going to see how they compare. So what does it say here? It says Hornsby had 276 more hits than Williams. So Roger Hornsby is going to be Ted Williams plus 276. And do we know how many hits Ted Williams has? Nope. So that's our unknown variable x. I always like to write it up with words and then translate it. Instead of just jumping to our equation, I think that's confusing for some students. So what I always like to do is write it with words, get our equation, and then solve it. So now what do we know? We know Williams is still x. And we know Roger Hornsby is going to be x plus 276. Now we can finish it, because now we know that Roger Hornsby is x. Or sorry, Ted Williams is x. My mistake there. Roger Hornsby is x plus 276, and that equals 5,584. Adding these together, we get 2x plus 276 equals 5,584. We'll move that 276 over with subtraction. And now we have 2x equaling 2x is going to equal now 5308. Divide by our 2. And that leaves us then with x equaling 2654. Now we want both players, so we need to go back and find both players. So Ted Williams got 2654 hits, so we'll go ahead and label that because he's x. That's going to go right over here. And what about Roger Hornsby? Well, Roger Hornsby is going to be 2654 plus 276. And that gives me then the total hits for Roger Hornsby to come out to be 2930. So 2,930 hits. So those are actually a little bit easier, I think, than the perimeter problems. What we're going to look at next is percentages. And we're going to look at a real-life example so that you understand how these percentages work. And the example that we're going to look at is sales tax. So let's see how we would solve this problem. If a TV costs, let's say, $800, and the sales tax is, let's say, 9.75%, what is the final price of the TV? This is just a kind of an example to illustrate how these percentages work. Now, if I go to the store and I buy this $800 TV, do I really pay $800? No. I pay more than that, right? Why? Because we've got tax involved. Now, what do we know about the tax? Well, the more expensive the item, the more you pay in taxes, right? That's how it works. So how do we calculate our tax? Well, our tax is going to be the cost of the TV times the percentage rate. So the cost times our percentage. So that TV costs us $800. And then we've got 9.75% sales tax. So that would be 0.0975. And how much would that tax then come out to be? So we've got 800, right, times 0.0975. And that comes out to be $78. So when we go to buy this TV, we're not really going to pay $800. We're going to pay more because our total amount then would be the $800 plus the $78. So we would actually pay $878. Okay? Is everyone okay with how we do that? It's a good example of how taxes relate to these percentages. Now, why I wanted to show this example was to talk about percentages. Whenever we have a percentage, it has to be linked to something else with multiplication. All right, so when we did this example with this TV, that percentage, that 9.75, it had to be multiplied by the cost to get the tax. So whenever we use a percentage, it has to be linked to something else through multiplication. So you can't just have a percentage added on, it has to be multiplied. So it's got to be multiplied by something else. This is an example I think we can all relate to. We go to the store, we buy some item, we know that that item is going to cost more when we actually check out because of our taxes. So now let's look at how we do percentage increases and decreases. And we're going to look at question 43. And this is going to kind of relate in a roundabout way to the tax problem that we just looked at. So question 42. When we look at question 42, we're going to be comparing, in this case, two different years. So question 42 says the U.S. population reached 321 million in 2015 and it is expected to reach 347 million by the year 2025. What percent increase is expected over this time period? Now, whenever we talk about an increase, that's an adding. So we're going to write this out in words first, and then we're going to fill it in. So what's happening to our population? Our population is going up. So we're going to start with right now, as of we're going to look, let's make sure we set it up right. We're going to look at what we want to end up at. And we want to end up at 2025. So 2025 is going to be 2015 plus 2015 times that percent increase. This is just like the total price of that TV. So that 2025, that's going to be like the total price that you pay for that TV. And that 2015 is where you start at. So that's how much that TV costs. That could be the $800. And this 2015 times the percentage increase, that's like your taxes. So it goes back to the same type of sales problem. Because you've got where you want to end up at, where you start from, and then what percentage increase you have. Now we can start filling in our values. And we're going to call that percentage. We don't know. So we're going to say that percentage is X. So we're going to replace that percentage with X. Now what do we know about 2025? Do we have a projected value? Yeah, if we read it, we expect 2025, we expect to have, with our models, 347 million. We know in 2015, we have 302 million. Sorry, 321 million. Sorry about that. And now be careful here. We're not just going to add on X. We're going to add on 321 times X there, because that is like your sales tax. Percentages have to be linked to something else. So you cannot just add on a percentage. It has to be multiplied. Now we can actually work this out, and we can come up with our percentage rate. So we'll move that 321 over. And we've got 347 minus 321. Well, that's a difference of 26. We're going to divide that by a 321. And that's going to give us our percentage rate as a decimal. Now, how far do we need to round? How far does it say here? It says to the nearest tenth of a percent. Now, percentages already have two decimal places. So we need 2, and another one makes 3. So it's tenth of a percent. So tenth of a percent is 3 places. So we're going to divide this out, and we're going to get our answer out to 3 places. It should be a decimal, because percentages are decimals. So 26 divided by 321. We're going to go ahead and round this out to 3 places. So it looks like it's 0.08 if we round 1. Or 8.1%. So that is what we would expect our population to increase by. We would expect it to increase by 8.1%. And again, how did we do that? Well, when we wrote up our equation, we think about this part right here, the increase part, that's like your taxes. And taxes has to be linked to a value with multiplication. They're very easy to set up once you remember that you have to have that multiplication component. Question 44. Let's now look at question 44. On Major League Baseball opening day in 2016, the payroll of the Cleveland Indians was $87.2 million. In 2017, it had increased by 44.3%. To the nearest tenth of $1,000,000, what was the opening day payroll for the Indians in 2017? We want to find 2017. So 2017 is here. And we're going to add in the value from 2016 plus 2016 times our percentage rate. Because that is the increase, right? That's like your taxes. So you've got how much the item cost plus the tax gives you that 2017 for your total. Now, we might know different pieces, but we're going to be able to solve it out. So we know that the Cleveland Indians on 2016 had $87.2 million to start with. So that's going to go here, $87.2 million. And then that was and then we wanted to know the value in 2017, so we don't know, but it had increased by 44.3%. And 44.3% as a decimal would be 0.443. So it went up quite a bit. And we don't know our 2017 value, so we're going to call that X. Is everyone okay with how I built my equation there? Increase means addition. If it was a discount, what would that mean? Discount would be subtraction, right? So this one's addition. We're making more money. So 2017 is going to be 2016 plus 2016 times that percentage increase. So let's go ahead now and figure out what this is going to be. And we want our answer to the nearest tenth of $1,000,000. So one place. So we've got that 87.2 times 0.443. This piece comes out to be, when we multiply, 38.6. And then we're going to add them together. 87.2 plus 38.6. We'll add those together. And we get 125.8. And this is going to be $1 million. So that is what we would expect, or was, their opening day payroll. So it increased substantially. But does everyone see how I set it up? Just like you would set up a sales tax problem. I always try to relate applications back to something that we can understand. We'll do one more of these, and then we'll take a short break. Let's look at question, how about 47? This is just like the sales tax problem from a moment ago that we talked about. So question 47. And we'll take a break after this question. At the end of the day, Lawrence found that the cash register at the motel where he worked had $2,725 in it. And this included the 9% sales tax charged. Find the amount of the tax. And this is something that you may have to do. Let's say we've been selling items and we had to pay our taxes. We haven't kept track of anything. But we know how much money we have in this drawer, and we need to make sure that we give the state and the federal their income, their sales tax money. So let's think about what we know. We know our total that we have to pay is going to be the sales plus the sales times our percentage rate. This is the tax. So that represents our tax, right? Nothing new. We kind of know how this is going to work. We didn't keep track of our tax, and we have to do that. So when we put these all together, when we open up that register drawer, we found that we had $27.25 total. And we don't know how much money we made in sales, so that's going to be unknown. And we know our sales tax rate is 9%, so that's going to be 0.09x over here, because that represents your tax. Okay, so here's the items. So this might be the price of the TV. This is our sales tax on that TV, and that's what the cash register drawer gets, what Walmart would get when you bought that TV. Now we can finish it. Be very careful with our decimals. This is going to be a 1 here. When we add those together, we then get 1.09x on the right, and we've got 27.25. So we'll divide out by that 1.09, and that then gives us our value of x. 27.25, divide that by 1.09, and that gives us our 2,500. That is not the answer to this question, because the 2,500, what is that? Well, the 2,500, that represents the sales. We want the taxes. Now, there's two ways of doing it. One way would be you take your $2,500 and you times that by your 9%, and that gives you then, when we multiply, watch your zeros here, I didn't put enough zeros. It's 0.0, now be very careful with those decimals. And we've got 2,500 times 0.09, that's 9%, $225. So that's your taxes. Now, what would another way be? Well, another way, kind of an easier way, would be to say, I've got a total of $2,725. And if I take off that 2,500, then I should still get the same what? The same $225, right? Because that's your taxes. Because X is not the taxes, X is the sales. So we then took our sales, and you can either take your total minus your 2,500 and get that 225, or you can take that 2,500, which is the price of the items, multiply that by your 9%, and you'll get the same $225. Just like buying a TV at the store. You've got to pay sales tax, and this is how it's done. We'll go ahead now and take a short break, and we will meet back at, let's say, 10:40. So we'll meet back here at 10:40, and then we'll finish out this section today.